All right, welcome to the Flyte Community Sync. My name is Martin Stein. I'm your host and I'm with Union AI. As always, a few housekeeping notes before we get started. This Zoom call is a recorded Zoom call. We'll share it later on social media. So if you have any comments about recording, sharing, reach out to me personally. The Flyte community is growing rapidly. So this is also a call to action for people who see this on YouTube. If you want to join us, go to flyte.org. You can join the Slack channel and you can join the Flyte community. We would love to have you there. So with that, let's take a look at the agenda for today. I feel today is going to be a 30 to 40 minute conversation, depending on how much information we get from our presenters, including Niels today. So I'm looking forward to learning after the community update a little bit more about a Flyte ecosystem project called UnionML. It's an open source project. We've spoken about UnionML. But we'll give Niels Bantilan today the stage to give us a little bit more details, more insights here about UnionML. And the second part will be about the Flyte roadmap. Eduardo is here today. Eduardo drives the open source development work at Union for Flyte. And we'll have Eduardo give us a pretty detailed overview about what we're working on roadmap-wise, but also a few other topics that he will talk about later. So with that, let's get started and dig into the community updates. My name is Martin Stein. Here's the first community update. So there's a recorded chat. I'm not going to spend too much time about talking about this, but you can go to the recording. It's on YouTube. It's Kathan Omar, who's the chair of Flyte.org as well. And you can see him talk to Sage Elliott about strategizing for data and MLOps. Obviously, very relevant topic. I feel like it's a great conversation with Sage Elliott on R squared. You'll find it on YouTube. The link is on the slide, and we'll share it later. Upcoming next slides. Upcoming, there's a machine learning hangout, which I'm super excited about. This is about Flyte and Ray, and we have two people who are experts. One is Richard Leon. He's with Anyscale. Anyscale's a company who open sourced Ray, and Richard is going to talk about Ray Air, and Eduardo is going to talk about the Flyte integration into Ray that we have. And this is going to be an event on September 21st in person in Bellevue, Washington. So if you're in Bellevue, Washington, Seattle, or if you plan to stop by, we would love to have you. RSVP pretty early. It's limited seating, first come, first serve. And it's a 2-hour event starting at 5 p.m. So all the information is there. You can go to the URL shown on the slide here, or you can just Google Machine Learning Hangout, Flyte and Ray, and you'll find the information. So I look forward, I will host the event. I look forward to seeing you there on Wednesday, September 21st at the Hyatt Hotel in Bellevue. Okay. Fabio, great to have you here. Hi to, where are you? In Berlin or already in Munich?
No, I'm in Berlin.
Okay, you're in Berlin. So Fabio is with Merantix, he's the MLOps lead. I'm not going to read through all of his experiences so much to talk about and what he has done, but there's one thing that actually I feel like is really, really interesting, Fabio, and that's on the next slide. Is a talk that you're going to give at the Sandra, if you could go to the next slide, please. It's a talk that you're going to give at the Open Source Summit in Europe. First of all, maybe you can introduce yourself real quick to the community and tell us a little bit about the talk, and I'll have a few questions for you. So don't go into all details because I might cover some of those questions too.
Oh, I'm muted. Okay. First of all, thanks for the intro, Martin. Yeah, I'm Fabio. I live in Berlin, Germany. I lead the machine learning operations team at the company called Merantix Momentum. We are a solutions provider. We build machine learning systems for industry clients in Germany. And my team basically builds the infrastructure and the let's say it like this. We built an internal developer platform that allows our ML engineering teams to self-serve infrastructure they need to train models and to deploy them and to monitor them. That's basically what my team does. I was a machine learning engineer before in NLP and computer vision, and I'm a physicist originally, so that's where my heart lies. my original heart lies, let's say. Now I love ML and Kubernetes, and like it's perfect when they're combined. So that's why I like Flyte so much. Yeah, so much about me maybe. If we can go to the next slide, then I'll talk about what I'll be talking about. So there is a conference in Dublin from the Linux Foundation, the Open Source Summit, and they have one format called the Open AI and Data Forum, where they talk about open source tooling in ML, big data analytics, etc. And I submitted an abstract half a year ago where for a talk in which I want to describe how we at Momentum use open source tools to build machine learning systems that that actually make it into production or stay there, because many projects fail there. And kind of the main argument in the talk that I'm going to give is that lack of automation and orchestration is the reason why so many projects fail, because teams treat ML systems like scientific experiments where lots of one-off manual work is involved. And then when the model is in the real world and the real world changes because, for example, the economic situation changes or anything changes, system breaks because it can't handle that, because the data distribution in the real world is very different. And if then you don't have any automated release process and need to do everything manually, maybe it's hard to bring a new model to production. And so I argue that when you want to build more robust ML systems or MLOps systems, you need to automate and orchestrate. And I'll also talk about Flyte in that talk, because we use Flyte in production very successfully. And could you go to the next slide, please? So this is one like a diagram that comes from an article from Google Cloud Architecture Center, where they discuss different levels of maturity that ML systems can take. So in the least mature stage, they say there's everything manual. And then as you become more and more mature, there's more and more automation. So the training of the model, so pre-processing of data, training of the model, evaluation of the model, etc., and then deployment and monitoring of the model is automated. And also the release of such a new version or a new version of such a training system is also automated. And throughout the talk, I explain how basically we build such systems using open source software and which software I would recommend at the different stages. And as you can also see here, basically for the workflow orchestration, I'm arguing why people should take a look at Flyte and why we think it's a good idea to do that with Flyte, that part. Now, there are lots of boxes on this diagram here. I think it would probably be too much to explain all of them now. I do that in the talk. So if you're interested, please take a look at the talk.
Maybe just one area. Obviously, I see with delight that you have Pandera for data validation I mentioned, and Niels is probably going to super happy seeing this as well. This is a good part. So when you look at this diagram, how long, I mean, obviously people don't start when they start out with that and you say, well, they put models in production. I always would say, and then the work is to keep it there, to update it there, not just putting it there. So how long does it take until people arrive at that kind of like holistic view? I mean, is that a process of a year or 2 years? That takes a while, I would assume.
Yeah, you're right. We did try different things and then also kicked out a bunch of things. So in the beginning, we tried, for example, to do the orchestration and the execution and retraining with MLflow projects, but that didn't work well for us. And we also tried to deploy models with MLflow, for example, which also didn't work so great. We had other orchestrators before that didn't work so great. So it took us like, I would say 2.5 years to come to the point that we're at today. And I don't think it's done. Like we'll continue to like improve it. Generally speaking, I would say though that we put all of all of the setup that we show here, or that this diagram shows here with the different icons that I put next to it, we put all of these into something like cookie cutter templates. So for our engineers, it takes like 45 minutes, I would say, to spin all of this up from scratch for a new project right now. So we have opinionated services for all these things where the operations team, my team, says, you want to monitor a model, I think this is how you should do it. Please don't mess with the details. This is how you do it. So yeah, it took a long time to get to basically being able to close the entire feedback loop of continuously training and deploying models and then monitoring them and being informed what you need to change and then going for another iteration. But for our ML teams, it's actually we're very quick to roll such a thing out. Of course, like the details, they need to fill themselves, right? Like coming up with data preparation, model training, etc. That can take a long time, but at least the infra part doesn't take long for them to roll out, I would say.
Right. And so now as a piece of advice, I mean, if you would give somebody advice, I mean, they don't have to spend 2.5 years on the experimentation. You have done that. And I feel like one important question is like, architecturally, how would you start? What team would you start with first? I mean, Flyte is an orchestration layer that is fabric, so fundamental. Would you start with the orchestration layer, or would you look at building an orchestration layer later on once you are clear with how to build models and so on in the first time?
I would say it really depends on your team. When you start with 2-3 data scientists that have maybe not a lot of experience in managing infrastructure themselves, then maybe hosting all this stuff on Kubernetes like we do ourselves is maybe not the best idea. So maybe try to get the service managed in a way, right? If you do have more people and you also have people that can run and maintain the infrastructure yourself, I would start with an empty Kubernetes cluster, install Flyte in there, install the ML for tracking server in there, install Elasticsearch, Prometheus, Grafana, Seldon in there, install a service mesh, and start building it, I would say. But it really depends on kind of the team that you have. The fewer people you have with infrastructure knowledge, the more I would argue to like getting this stuff managed. Does that answer the question, or was it?
Yeah, I think it's very important, because people, when they look at this stuff, they might feel overwhelmed just looking at it, like, where do I start? What comes first? And then I think your answer is very important. It might depends on how big and what your team is, where the competences are. And the second part is when you have a team that's small, I mean, or just don't have all the competence, how do you ensure that you develop this kind of like DevOps, MLOps culture in an organization? I mean, you have done this in your organization. Maybe there are a couple of ideas that you can share with us. What does it take to develop that DevOps, MLOps culture?
Mm-hmm. Yeah, I'm happy to. Maybe I want to add one thing to the question before. So I did basically this article that I took this diagram from. They explain like the least mature way to run an MLOps system is by having a bunch of Jupyter notebooks and a human connects them. So the human is the workflow orchestrator in a sense. And they argue that the first thing, so if you're there, which makes a lot of sense to build prototypes, right? That's how prototypes start. Then I would say the first thing you should do is you should modularize your code, make it testable, put it into modules, because that is the prerequisite for putting it into Docker images, which is the prerequisite to running it in an orchestrated way. That's what I would start. Take like the parts of your code that you want to reuse, take them out of a Jupyter notebook, put them into Python modules, unit test them. So that's where I would start, because that goes a long way once you want to orchestrate these different steps in a containerized environment. So maybe that, in addition to my previous question, where do you start? Yeah, so, okay, for the second question now, kind of the MLOps, the DevOps MLOps culture. First of all, I don't think we have the perfect answer. Like, it's very difficult to do, actually. I think what we discovered is in the first iteration, we basically said, here are cookie cutter templates for the infrastructure, use them. And we now find that that doesn't work very well, because if I give an ML engineer 1,500 lines of YAML, maybe it works if they apply them, but it's very difficult for them to understand what's happening if you do that. And I think you need to abstract these 1,500 lines of YAML and put them behind a simpler API, where the ML engineers can specify the few variables they actually need to specify and then understand what's happening. So I think what we're trying to do, right, like have been trying for the past year, and I think it's really, for us, it has been the right way to go, is not giving the ops team that tries to build the tooling for the company to be able to self-serve infrastructure. They configure infrastructure in an opinionated way, but then they abstract it away behind a simpler interface, so that people understand, yes, I want to install Flyte now into my cluster. And the things that I need to specify now is which projects do I want, and what are the kind of the resource quotas for those projects that I want. But the rest, like there's a giant YAML file of a Helm values file when you want to run Flyte, right? most of that is something that I wouldn't want the ML teams to change anyways, because it will probably break. So we basically create our own Helm chart that uses the Flyte chart as a subchart and contains an opinionated way of how we configure this for our cloud environment. And I think for us, this has really been key to reduce the complexity by basically abstracting the infrastructure away and only let the user specify what we actually need them to specify, but not hundreds of other lines of code.
Interesting. So basically what I hear you say here is there's developing that culture is an ongoing process. It's not a process that stops at some point. I mean, and you have to abstract and simplify, some levels of complexity for team members who shouldn't be exposed to that complexity. I think that's what it sounds like very much. If you have a very capable infrastructure, give each and every one and the teams, ML teams, data science teams, just what they need, but then actually let them do what they're best at. I think that's what it sounds like.
Exactly. So that's the mistake we first made in the first iteration. So the ops team created, in my opinion, super powerful infrastructure, and then said, yeah, look, we have these services now, perfect. They solve your problem, and people were like, yeah, but I don't understand what's happening because it's just so much code. And then that's exactly what we did now. What you said, and we went back and said, okay, what does the user actually have to specify to use this? Let's just hide away the rest, so that it's an opinionated way of configuring this, and we make it simple so that people can use it. Because I mean, of course, you can't expect every ML engineer to understand all the finickies of Kubernetes.
Right. And I would assume as you move along that kind of like learning culture about obviously ML ops and DevOps, at some point you are able to see obviously the impact by reducing the boilerplate code that you write, because now you have a lot more automation, a lot less boilerplate code, a lot more handled by the systems. And I think that's one of the benefits, having a lot less errors to deal with, and you're much faster when it comes to deploying things. So the benefits should be very clear on that side.
Definitely. So by introducing automation wherever possible, it allows us to bring a new, when we need to like change one small thing, maybe in the training code, can just click a button and then the new model version is deployed, and then there's like a decision gate somewhere where we actually, like, the human clicks, yes, I want to deploy that. But by basically automating the release process of an ML model this much, for example, using Flyte, you can, the burden or the barrier to releasing new model version is very low. You can do it very often, and by doing that, you can keep your models sharp. Let's say it like this, because you can always train them on new data, and when the real world changes, not a catastrophe, because also changing the model is kind of a minor thing then. So yeah, that's why also advertisers talk now here, because Flyte has helped us a great deal doing that, kind of keeping our models up to date.
Great, fantastic. I think you have one more slide. Let's take a look at that. I think.
Yeah, that's also.
I also have one question. Hey, Fabio, but at the end I will ask the question, and this is more for the community and purely from the tech side. But we can do it after the slide. I didn't know.
Oh, please, we can go back to the previous slide. I can't.
It's not about the previous slide. It's a meta question. It's like, if one thing that you really have liked when working with Flyte and that we should continue to invest in as a community would be great to know, and maybe one future looking thing that we should as a community look at.
Okay, so you're asking what maybe if I have from all the features that Flyte has, which one is one that I really like?
Yeah.
And if there's
like what has given you the soup, like the ability to move forward really fast, right? What is that one thing? And then what is the one other thing that we should add?
Yeah, okay, so picking a feature that the one feature that is to me the most important feature from that is actually very difficult, but I think I'm going to go with versioning. It's very hard, like it will be impossible for you to not version your tasks and workflows in Flyte, and it's great that Flyte pushes you to do that, because you need to do that, and Flyte forces you to do that. And also I really like that Flyte comes with the different domains. We map them to like feature branches, staging branch, and production branch, which is kind of obvious. Actually, we matched into feature branches, main and tags, but comes down to the same thing. But it's really nice because it forces you to think in that mindset. Okay, like now we try something, so this is just the just a development version of the task, but still half a year later, we can reproduce what the development version did, then bring it to staging, then bring it to production. But even half a year later, being able to run kind of some feature branch version again. So that's a really good feature. So we really enjoy that. And maybe if you allow me to add one more feature that I think is just as important for us, being able to run different tasks with different resources. Sounds like a no-brainer, but actually it's an important thing that not every orchestrator can do. So what we do very often is have like data preparation tasks with like ephemeral Spark clusters, and then training just as Python task, or also like PyTorch task, TensorFlow task, and being able to orchestrate that without writing a lot of boilerplate code. That's what originally tipped us to Flyte, and I think that's just a really cool feature that others should ask themselves why they don't have it. Maybe feature that I'm missing. So Flyte has lineage, right? So when you return a data set from one task, put it into the other task, train a model, and then return the model from the train task to the deploy task, Flyte knows which model version kind of was the output to the task that had the certain data set version as an input. So this lineage information is there. You cannot see it in the UI, right? So there are tools like Marquez or other lineage tooling. I think it would be great if these could be plugged together so that I could just have a dashboard running in my cluster and I can look at the lineage information kind of in the visual way. That would be a great feature, I would say.
Okay. Yeah, actually, there is some work. I don't know if those folks are here, but there is some work with Data Hub. I think that's ongoing, and I think there are people from Marquez also reached out. So fantastic. Thank you, Fabio. That really, I'm sure the community will take that and move it forward.
Okay, yeah, so this is another slide that I took from this article that I find really interesting that I mentioned before, that I also bring up in the talk. Kind of the key to, I heard the saying before, I'm not sure where I heard it, but like classical software gets better over time because people iteratively improve it and fix bugs in kind of an iterative manner, kind of this feedback loop. Oh, something breaks, let's make a PR, and let's make a feature branch, fix it, PR, merge. Another bug, feature branch, implement feature, add a new task, PR, merge, right? This iterative manner improves classical software, but the ML systems, they just die typically, right? So to run them successfully over time and improve them, you also need kind of this feedback loop. And in order to have this feedback loop, you need a lot more infrastructure and stuff than for maybe classical software, which was on the previous slide. But ultimately, you also want such a feedback loop. You want to have some pipeline training code in the beginning that needs to be packaged and through CI/CD needs to be registered. In this case, for example, with the Flyte server, and there it runs on a cron job. Every day trains a new model on new data, deploys it, and then every once in a while you realize, oh, we missed something. We need to go back to the initial code and maybe filter out part of the data for some reason. So you go back to the source code, change the pipeline code a bit, do the CI/CD, register and release a new model version, and then tomorrow this version runs in production. And then either you go back to the beginning because you realize something else is wrong, or you maybe automatically trigger new model training with the same pipeline version. But ultimately, you aim for this kind of this feedback loop thing, also for ML systems that we have now in non-ML systems and classical software systems, right? So that's kind of the goal. And in the talk, I argue that this is what you need in order to not lose your models due to model shift because they just die. So this is what I want to show with the slide, but I go into more details in the talk. So if you're interested, then either reach out or watch that talk.
So the talk, just a quick reminder before we move on, is September 12th to 15th. So what is the date specifically? Is that the 12th or 13th of your talk?
I think it's the 14th, but I would have to also click on the event link there.
Okay, the event link is here. So I would highly recommend to follow it. And you can watch it live, I assume, right?
Yeah. Yeah, it will be live now. And okay. Maybe also if you're here because you're interested in Flyte, right? I think maybe what is interesting Flyte related in that talk is how we do the connection from, you're in your Git repository now, you change the learning rate. How do you bring a model, like a new training system in Flyte to production that trains a model the next morning? Like, so how do you do the connection from your source code to having something run in production? So I go a bit in detail on that because we spent some time figuring out how we want to do that. So
Right.
maybe that is interesting.
I think we should capture that information on the Flyte org page, on the events and material that you have that goes with that as well. So people who are watching this know where to go. So I'll talk with Samita to get this done. Awesome. Fabio, thank you so much for your time. This was always super interesting talking to you. So I look forward to your talk at the Open Source Summit Europe 2022 in September next week or week after. And let's move on.